Hey guys, welcome back to another episode of Simulos. Today is going to be an absolutely fantastic day, I'm pretty sure, maybe, I don't know. Actually, I don't know why I said that because I really can't validate that in any way. But anyway, let's go ahead and get started. So today we're taking a step back from the Huffman encoding stuff. Not because the Huffman encoding stuff is not interesting, but because I've got an idea that I want to test out. And I figure, hey, if we're going to test it out at any point in time, we might as well test it out now. The idea deals with finding determinants and things like that. So determinants are, well, incredibly easy to do mathematically, but I was asked by one of my viewers on my eigenvector video to do a video on determinants, and I figured, hey, look, determinants are incredibly, hey, that yo fan, your fan, and determinants are incredibly useful for a number of different reasons. So I figured, why not just do a video on them? I mean, at this point, we're kind of going through, at least on YouTube, and doing very, how do I put this? We're doing simple things on YouTube. So I figured, let's just continue the trend of doing simple things until we reach something that's actually interesting. And you know, if people don't like the videos, that's fine at this point. You know, it's perfectly fine. But this one was requested, so I figure at least one person will watch it. Okay, so let's go ahead and open up Zernal and let's talk about what we're gonna do. Let me just bring this up here, Zernal. Okay, so what are we gonna do? Again, today's and maybe tomorrow are gonna be kind of one-offs, you know, they're just making animations and things like that to see what looks cool and what doesn't. Here's the idea. If we take any given matrix, let's say, I'm just going to write a random one down, 1, 2, 3, 4. 1, 2, 3, 4. Wasn't that random, but I'm human, I can't really do randomness very well. Okay, the determinant is simply going to be 1 times 4 minus 2 times 3. Okay, so we get a total of 4 minus 6, negative 2. Okay, so what this means is that the total area of the box after finding the determinant is going to be 2 times the area of the initial box. Hey Gusterwin, how are you? Sorry about that, we're taking a step away from Huffman encoding today. I guess we could have done it for one more day, but if you're interested, I can show you some GIFs and things of what we had been working on. It's almost done, but not quite there. Anyway, so today's probably gonna be mostly Python code and stuff like that. Anyway, so the determinant is going to be negative 2 here, and it should be that the determinant is somehow equivalent to the area after matrix multiplication. So the idea is we do a transformation, and the area in the box before matrix multiplication should be, I guess, 2 times less than the area after. Totally not Zuki. Hey, how are you? Okay, so let's see, what are we going to do? Let's take a step back and talk about what this means physically. So, we've done 2 things on my YouTube channel so far, really, well, 4 or 5, but I don't know. Again, I kind of deleted like 100 videos the other day, so we're kind of, it's weird if you go to Social Blade, which is what I do for checking my stats sometimes. I have like a negative 20,000 view count at this point for the past month because I deleted so many videos, but that's completely beside the point. Anyway, we've done 2 things. We've done eigenvectors, and likewise, and similarly, eigenvalues. And we have also done Monte Carlo. So I figured this is the perfect time to cover determinants, because we can show this exact principle. It should be super fun. We'll see how far we get. So here's the idea. The idea is actually super simple. We're going to, new page before, we're going to take 4, well, we're going to take a cube. 1, 2, 3, 4. 1, 2, 3, 4. Pretend I can draw cubes. 1, 2, 3, 4, 1. Oh gosh, this is complicated. Oh crap. That looks like a cube, right? Okay, pretend there's a cube. We're going to take the cube, we're going to multiply it by the same old transformation matrix that we had been using, which was 2, 1, 0, 1, 2, 0, 0, 0, negative 3. Same one we had been using last time. And we're going to show, hey, look, this does transform, yada yada. Okay. After the transformation, we'll have another box, which is like something like over here. or something like that. Yeah, I should have drawn it differently. Anyway, we'll have another box, and the box is going to be something like this. Pretend I can draw. I can't draw. Anyway, it's going to be something like this. So it's going to be something like that. And then all we have to do is find the area of the two boxes. So what I want to do is after this, I want to perform a quick integration. And we'll just use Monte Carlo for that since we've already introduced Monte Carlo. And I think it's going to look pretty cool. So we'll kind of draw one box, show the transformation, show the original box, then draw a bigger box, show the Monte Carlo integration of that with a whole bunch of translucent spheres. And then, man, I'm tired. And then we get into the actual math. And the actual math, I don't know how to visualize the actual math. I feel like we might have to do all that on the blackboard. But there's a few things that I want to show. So, a couple different ways to find determinants. One is to do what I did before. So let's say you have a 3x3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that was a 9. The first way is to say 1 times this box right here, right? And so that's going to be 1 times 5 times 9 minus 6 times 8. Then we subtract out 2 times 4 times 9 minus 6 times 7. Boss like sorry about that. I'm visualizing some math. Right now we're doing determinants. This will probably take a day or two, and then we'll get back to the Huffman encoding after that. I realize, guys, I've been consistently pushing back the Huffman encoding, and there's a reason for that. It's because the further along in the Huffman encoding I get, the closer I have to get to doing dynamic Huffman encoding, and I gotta be honest, I am just lost there in the literature. I cannot figure it out to save my life. And I know it's not that difficult. I know, like, sure, people do it all the time, and you know, like, it should be simple. And in fact, it probably is simple for a computer scientist, but for me, it's a little bit difficult. So I have to kind of think about how I want to do it. I'm most of the way there, but I'd like it to be that the moment we finish the visualization of the Huffman stuff, we move immediately onto the dynamic Huffman encoding. So, and honestly, the Huffman encoding is going to give us, you know, basically 2 videos. It's going to give us one on basic Huffman encoding and another on dynamic Huffman encoding. So that's pretty cool. Anyway, the third one is going to be plus 3 times, let's see, 4 times 8 minus 5 times 7. All we did is we took each element here. So we took this element and we multiply it by this box. We took this element and multiplied it by the determinant of this box. We took, this element, and we multiplied it by the determinant of this box, minus the 6. This box. Okay, and that's all we did. That's one way to find the determinant. Another way to find the determinant, which is a way that I had actually never been introduced to, but is actually the definition of doing a determinant. Sorry about that. Let's say we have a 3x3 matrix. We're going to write down 1, 2, 3, and then we're going to find all of the what are they called? When you flip them around, what are they called? Shoot, I know this word. We're going to do this. So we're going to say 1, 1, 2, 3. Then we're going to say 1, 2, 3, 1, 3, 2. Shoot, what are these called? All of the, you flip all the numbers around. I don't remember what these are called right now. Not inverse, no, it's, here, I'll show you what it is, and then someone in chat is definitely going to know what this is. So it's 1, 3, 2, then we do 2, 1, 3, 2, 3, 1, 3, combinations, yeah. Permutation. There we go. Thanks, Abron. 3, 1, 2, 3, 2, 1. There we go. Permutation was what I was looking for. I appreciate that. Sorry about that. For some reason, my mind would not pull up that word. Anyway, good. Okay, so you guys are way ahead of me then. Anyway, this is basically the definition. So it's going to be A11, A22, A3, 3. Then we subtract out A1, 1, A1, 3, A1, 2. So we did 1, 1, 2, 2, 2, 3, 1, 1, 2, 3, 3, 2. Then we're going to add in, let me see here. Looks like what we had to do was flip 1, 2. So it's going to be plus A, what are we? 1, 2, A, 2, 1, A, 3, 3. Oh, wait a minute. Is this one flip or two flips? I think this was one flip. So it's minus. So if we only have to flip once, it's going to be minus. If we have to flip twice, it's going to be plus. And then basically we just add all these permutations together. So plus dot dot dot. If you've let me be so kind of hasty here. So the idea is just we work with all these permutations and we do it this way. The third way to find the determinant is simply by multiplying all the eigenvectors. So we do multiplication of all the eigenvectors. So we say, what are eigenvectors? So A, V equals lambda V. So we find these vectors. Oh, I'm sorry, values. Multiplication of all the eigenvalues. So obviously, like we did before, if we find all the eigenvalues, we can put them in a diagonal matrix like so. A, B, C, 0, 0, 0, 0, 0, 0. And if we multiply these guys together, we should get the determinant. So this should be the determinant. Okay. And then the last way to get the determinant is to do it completely numerically, which is super slow, but is totally possible. And for it is do the matrix multiplication. So matrix multiply, integrate, and find the area. Well, let's see, find the area ratio. And that will give you the determinant also. So there's a whole bunch of different ways to do the determinant. Incredibly, in a way, mathematically simple. But again, leads to a whole bunch of interesting stuff in the future. So I figured we'd take a day or two, take a step back, do this kind of thing, because I think it's something that people will enjoy and will use a good bit. So I think that's pretty useful. Okay, so let's go ahead and get started. There isn't really so much to do here with the intro because it's mathematically simple, but we have to kind of do some things a little bit more complicated when we do the actual, how do I put this? When we do the actual, let me see, visualizations of this. So we'll see how far we get. Again, so of these definitions, let's see. This one is pretty easy to visualize. This is something we can do. This one we can also visualize. It kind of makes sense in a way, right? Because again, following this definition here, that we matrix multiply, we integrate, and we find the area ratio of the areas, we know that the eigenvectors are basically directions in which we stretch, right? So you can kind of imagine, okay, well, if we stretch this far in this direction, this far in this direction, and this far in this direction, then the box is going to change by this value. So we're going to test basically a whole bunch of these two ways, definitely. The other two ways are mathematical, but they also have very interesting applications. So basically, we are not going to show these two on stream because there's not much to visualize here. You just kind of do it, and that's fine. This one right here in particular is going to be, I think we can visualize it, but it's not going to be the easiest thing to visualize. So basically, I'll do this over the weekend. It's not something to do on stream. Okay, so that's that. I think it should take 1, maybe 2 days. So this is going to be kind of a short side project, and then we'll get back to the Huffman stuff directly after that. And again, the Huffman stuff, the only reason I'm kind of delaying it is because I am terribly afraid about doing the dynamic Huffman encoding. In particular, the algorithm I have to cover is known as the Vitter algorithm. And I don't know, I'm having a lot of trouble with it. I don't know. I don't know why. Okay, so I'll look into it. I am looking into it a little bit more. Hopefully I can figure it out. But anyway, it's the Vitter algorithm. I'll just kind of give you guys this here. And that's kind of I don't know. It's a little bit challenging. Okay, so let's go here. Let's cd into projects, Simuleos, and let me see. What do we have here? Let's go into cd visualization. Now let's make a new directory, and the new directory is going to be for determinants. Okay, so now let's go into there, cd determinant. We're going to copy a couple different files over here, so let's ls one directory back into eigentest and see what we have here. So here we have all of the MP4 files for the eigenvalue stuff that we did before, and just in case you have not seen that before, yeah, you're right, Gustorn. It's just, again, I've done Huffman encoding only analytically before. I'd never done it numerically, so that was kind of interesting. Okay, so if you hadn't seen this before, let's go ahead and do mplayer, and let's do, I don't know, it doesn't matter. We can just do, I don't know, eigentest out with, let's do full data. Why not? Let's do lines.mp4, and now let's do loop, oh, sorry about that, loop 0, then we do vo x11 so you guys can see it. Okay, and now we're going to full screen that. Okay, so this is one of the transformations from the eigenvector video. Basically, we're going to be doing the same transformation, just in a little bit of a different way. We'll show the transformation, then after the transformation, we'll kind of do some things to the transformed box. So we'll leave it in the transformed state for a good bit of time, and then we'll kind of go from there. There's a couple tricks here that I didn't show you guys on stream. Drawing the lines isn't exactly the easiest thing to do. Ran into some trouble there, but that's okay. Everything is kind of sort of done at this point, so we just have to basically perform a new transformation on a new set of points, do the transformation, and hopefully this will be the easy part, creating an animation like this. The next part will be a little bit more difficult, which is creating basically a, how do I put this? Creating basically the integration of this. But again, I don't think that should take so long. I think that should take like a day. And then if I want to do some dynamic camera thing, sure, we can do that too. No big deal there. Okay. So let's go ahead and quit that, and we'll go from here. I need to be watching YouTube videos, but I'll keep you on. I'll be back hopefully. Speaking of simple math, that's fine. Bosslickmon, so what we're doing there is, because you may not have seen it before, what we're doing there is we're basically, just doing a simple transformation. So we took a grid of initial points right here. So we took our grid of initial points, and then what we did is we multiply that grid of initial points to create this here. So after the grid was multiplied by a transformation matrix, it turned into this. And we just visualized that transformation. We showed all the points moving from one point to the next point. And that's all we did. So it's fine to do this as long as we don't focus so much on the animation. Even though the animation looks cool, in actuality all we're doing is going from this point here to this, oh, sorry about that, to this point here, right? So that's the actual math thing. We're going from one point to the next point. The matrix multiplication is kind of what we're seeing in the middle there, some sort of magical way to go from one point to the next. Okay, so now I'm going to take a quick sip of water, and then we'll go ahead and get started. Again, I'm not expecting this to take more than a day or two, so I think this should be pretty quick. So it'll be kind of a relaxed stream. If you guys have any questions, comments, concerns, let me know, and I'll totally address those as soon as I see them. Okay, so let's see what we got. So we're going to ls back into the eigenvector or eigentest directory, because that is what we used for the eigenvector video. And what do we have here? Eigentest.py. That's the one we want. So let's go ahead and cp, cd into projects, Simuleos, and determinant. Oh, sorry, visualization, and then determinant. What do we have? Are you using transformation matrix and apply it to all the points there? Yeah, so each point is an individual vector, and we're multiplying each of the vectors by the transformation matrix. In fact, we have a video or a code doing exactly that, so I'll show it to you in just a second. So now we're going to cp, let's see, eigentest, and then we want to do, what do we want? Eigentest and we'll move it here to determinant.py. Okay, now this code is super messy, and I'm going to let you know that. It's really hard to read. We did make it on stream, and it's just, it's something else. It's from a while ago, so I'm letting you know that. The other thing I want to do is CP. That was a VP. I want a CP. Another file here, and that file is going to be, I think, back here. Let's do eigen. Where is it? I guess it's gonna be under linear algebra. Other.cpp. No, that's not it. Where is it? Is there an eigentest.cpp anywhere? Nope. Okay, where is this guy? Archive, Huffman, BEC, invisible lens tests maybe? Area checker, mc.cpp, mcsphere.cpp. Nope, none of that is it. Here, let's go back a couple of directories. cd ls, cd ls. What do we have here? DMRG, CUDA, FDTD, FX integrate, Huffman, Igloo, visible lens, molecular dynamics, optimal control, orbits, test, tunneling, visualization, quantum Monte Carlo. It's probably in DMRG. And yes, it is. Okay, so let's go back. Let's go to visualization, determinant. And now let's CP, DMRG, one second, DMRG, and eigentest. And we're going to move it here. Okay, so let's go into that file, eigentest.cpp. Now, I realize I could have just used this code again where it was before, but that's fine. We'll just use it here for now. Basically, all we're doing here, it's a super simple code, only like 250 lines long. This is what we're doing. We are creating an output file called out.dat. We have a size, where size is going to be the number of points in each dimension, right? So we'll say 1 point in X, or 5 points in X, 5 points in Y, 5 points in Z. So that's going to be 5 times 5 is 25, 125 points. And you'll notice that in this video here, there are exactly 5 by 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there's 125 points total in this box. Okay, so what do we need to do? All we need to do is change this code up a little bit so that we do basically the same transformation again. So again, here's the array. We have 1, 2, 0, 2, 1, 0, 0, 0, negative 3. And basically all we're doing is we're creating the array and creating position and multiplying each point in the grid by that position. So what I'd like to do is make it so there's only 2 points in each dimension. So it's 2 by 2 by 2. So there's one for essentially every, oh wait, no, there should be 1, 2, 3, 4. There should be 4 total. Let me think, how do I do this? Let's see. I want, let's see, 1, 2, 1, 2, 3, 4, 5, 6. No, there should be 8. 1 second, let me think here. I'm being really stupid here. 2 cubed is going to be 8. So yes, I want 2 in each dimension. So let's do that. Let me go up here. And let me change int size to 2. And this should create a very simple cube to work with. So here's what we're going to do. We're going to go ahead and write this. And then we're going to go to the top where I put in compile instructions right here. So let's grab this and go from there. And again, guys, I totally understand if this isn't your thing. Let me know, and we will. If you know, I'm okay with negative feedback. You know, so if you guys don't like this episode, that's fine too. I did today my first ping pong game. Ah, super cool, man. Okay, so now what are we gonna do? We're gonna run a.out. Okay, and now we want to. What do I want to do? I don't remember. Oh, I know now. I want to run eigentest. So let me go into the eigentest.py file, which is now determinant.py, and let's see what we have here. So we have everything we need. So create connectomy 5. What do I read into that one? Create connectomy. Next, create connectomy resolution. Okay, so we want to change that to a let's see, create connectomy. We want to change this to a 2. Okay, so let's go ahead and let's see, what do I want to do? Let's go down. Well, let's just see what happens if we write it, write and quit. And let's run Blender. Actually, 1 second. I think it needs to be Input is out.dat. Yes, good. So let's do blender -b-p. What do I want to do? Determinant.py. And this, I guess maybe I could use a bot. Let me see. So what do we do here? Length of connect to me is 12. That is not correct. So let's do determinant.py. And let's change this to 1. So now let's do blender -b-p. Okay, good. So now we're generating a whole bunch of frames. I don't remember how many frames I generate. I think 30? No, okay, maybe 60? I have no idea. I don't remember. 60? Good, 60 frames. Okay, so now Blender quit. Let me ls real quick, and I have an out.mp4. Let me do mplayer, out.mp4. 1 second. Then I want to do loop 0, vo x11. Okay, so that wasn't what I wanted. Okay, so let's do, let me go into the file one more time. What do I want? I want to do, wait, what am I doing? Determinant.py. Let me just make sure I can get this done. So connect to me is here. What did I do? Input MD. Let me see. Connect to me there. Append, create. I feel like something's wrong here. Let me go here, right and quit. Let me go into what I want to do. Data. Oh, what did I call it? Out.dat. There we are. We are visualizing just determinants and things like that. This is kind of a bit of a problem. Let me see here. What do we have here? It looks like each time step is only giving us 2 points. We want more than 2 points per time step. Definitely. We want, how many points? We want a total of 8 points per time step, which we should have. Okay, so let's go ahead and right quit. Now what do we want to do? Let's go into eigentest again. .py. Let's see. Let's change int size to 3, and let's see what happens. Now let's run the last g++ command over here. I don't know why I'm super hungry. I've been getting super hungry lately. Now let's open up out.dat. And let's see. Out.dat still looks ugly. Why is it doing this? 1 second. Let's go ahead and quit here. And let me go into eigentest.cpp. And let's try change the size back to 5. Let's run g++ again over here. A.out. vi out.dat. Yeah, still doing the same thing. Quit. 1 second. Let me think. What else could have done? 1 second. Let me do remove out.dat. A.out. ls. Definitely creating the out.dat file. Okay. So let me go into the eigentest.cpp file and let me see what I'm actually outputting, because I feel I'm not outputting what I want to output. Okay. So let's change this to a 2 or something like that. Now let's see. Creating initial X, Y, and Z locations. I have this commented out. What do I actually have commented in? It doesn't look like I have very much at all. What is this? We have absolute EV1, EV2, and EV3, creating initial X, Y, and Z locations. Okay. So in this case, what I was doing was I was creating a, how do I put this? For the eigenvector video, I went through and I created basically all of the different eigenvalues, and I kind of showed that, you know, these guys don't at all rotate or anything like that. So now we don't need any of this. So we can go through here and we can remove this for now. Okay, so now we say count equals 2. We don't want count to equal 2. Count should equal more than 2, but that's okay. So let's go ahead and dd there, here, and oh wait, nope, I needed one of those. And then we're gonna go down here and say count should be equal to 8. Now let's go over here. Let's run the last g++ command. And let's see if it runs. It does. So let's do a.out. Now let's go into out.dat. Okay, so this one, no, I don't want to close that. Okay, let's see. What do we output? We output -1, 2, 3, 4, 0. Okay, so it looks like we have a box that goes from 0 to -1, which I suppose is okay. And let's see. What are we doing? Count is here. So do I creating initial X, Y, and Z locations? Let me see. Frame is 60. Double X velocity. Where am I actually outputting? So let me see. So we go... I probably screwed something up here. Let me look for count. Ah, there it is. Count equals 2. We want count to equal 8. So let's go here and let's run g++ one more time. And let's do a.out. Now let's check out.dat. Okay, so now we have 8 points. Let's see what happens if we visualize this. So let's go over here. Let's go over here. And let me go into determinant.py. Okay, so we're going to create connectomy, except this time we're going to use 2. Which should mean that we have... Oh, actually, let's just check what happens. So we're going to run the last blender command. And it looks like it's running. Let's see what happens. It's going to take 60 frames, so a little bit less than a minute. But that's okay. And then we'll run the last mplayer command. Okay, so this is exactly what I want to see. You'll see that everything kind of rotates and moves upwards. That is good. This is one transformation that seems to work. Now, what I want to do is make the new transformed box, how do I put this? Completely inside, rather, I want the old box completely inside of the new transformed box. So let's do that. And we also have to change line width and stuff like that, but that's going to come with time. So let's go into what I want to do here. Eigentest.cpp. So basically we have to make the center of the box 0, 0 at the origin, so that with the transformation we don't see any transverse motion. It's just the box transforming, which if you remember from the previous mplayer stuff that we did, let's do sure, this one. The transformation here is clearly not really moving, but all the internal points are moving. So for example, if we watch, let's say, this red ball at the very bottom here. Okay, so if we watch this red ball right here, through the transformation, it is now up here, right? So we've shown that it does move. All of these points do move. So what we were doing was we were taking, like, maybe this ball right here, and if you watch that ball, I guess that one doesn't move very much, but some of them do move, and we chose 2 that just showed transverse motion upwards. So we need to kind of fix that. So let's go through here, and let's just let's do it. So let's also remove unnecessary lines. Since this is going to be in a completely different file, we're not going to need any of this guy. Let's see, what's all this? Creating initial X, Y, and Z locations. I think writing a file in correct format. Why is that all commented out? I'm not sure. I'm not sure what that was. This is me not really sure what I was doing with the code. That's what I get for writing code and not commenting. Of course, I didn't think I was going to use the code again, so that was kind of why I wasn't really commenting on it. So let's go ahead and write and quit, and let's move eigentest.cpp into determinant.cpp. Okay, now let's go into determinant.cpp. Let's go here and let's change the name because we are doing several modifications to it. So determinant.cpp. Okay, so let's go ahead right there. What are we going to do? We're doing basically the same thing. I want to use the same transformation and everything like that. However, the points that we're using is going to be a little bit different. Instead of starting at -1 and going to 2 times double of size of I, we're actually missing some points here. So what I want to do, let's see, if I is equal to 1, that means it's going to be double of I. But what I want to do, let's see, size is 2. So I want to kind of do this a different way. I want to say 2 times double of I, and then I want to do +1. So double of I plus 1. Double of I plus 1. Let's see, so this should be, let me think here, double of size. Oh, no, that's not what I want to do. I want to do double of size -1 down here. Subtle difference, but kind of important in this case. So we're going to do this, and we should do -1. -1. Okay, we're going to do that for all of these. And again, guys, if you guys are not interested in this, let me know. Hey, Dave, what's up? -1. In general, I wanted to do... So I'm kind of hit and miss with this. So on the one hand, I do enjoy making these visualizations for everyone. On the other hand, they do take a lot of time, and I don't normally have all the time to do it. So it's one of those things that I enjoy doing, but I need time to do it. So we would have to... we'd have to do it at some point. And I think it's best just to do it on stream rather than doing it and then having some sort of random... oh, that's good. Some random video or something pop out. Okay, so now we have things that are clearly from -1. So it's -111 to 111. So we have all the elements. Let's go here. Let's go ahead and write. And let's run the last Blender command. So it's going to be Blender. And let's see what happens. So we're going to give it a second to do its thing. And then we just have to, I guess, go from there. So what do we have? So in this case, we want, I guess, everything to be a little bit thinner than in the other case. So let's see. Let's do the last mPlayer command. Here we are. Okay. So note that all the balls are black. That is because they are all moving the same distance. In general, they're all going to be the same color in this simulation because last time they were colored based on the distance that they were moving, but here they're all going to be moving the exact same distance. So that's one thing that we need to fix. Let me think. But this is pretty much exactly what I wanted to see. Now, the next thing we need to do is go into, hey, iCare, the determinant.py file, and move the camera back a little bit so we can see all the transformation. So let's go into determinant.py. And again, guys, this code's a little bit ugly, but it basically has a general structure. So we have parse data, which goes through all of the data that we just output, which was, let me go here, .dat. And it's basically all 8 points for all 60 frames. We just go through, we parse all the data, and we create a frame for each of those points. Now, this could be cleaned up a good bit if I could figure out how to do keyframes appropriately, but that's something to do on my own time, not on stream. Right now we have something that's working, and we should probably work with that. So what is this doing? Basically, we're creating something that I called a connectomy, which is a thing that connects all of the points. Now, I know connectomy means something else, but I don't know exactly what it means. And since it is connecting all the points, I just went with it. There we go. So we're creating it. I give it some sort of resolution. The resolution in this case is 2 because we only have 2 points in each dimension. And then what we do is we just connect all the lines. The create connectomy actually took me some time to think about, but that's okay. Then what do? We basically input all the data and we plot all the points at each of the time steps. It's not particularly challenging. Now, one thing to note is when we place the spheres, we do read out max velocity and min velocity, which is then used for colors later on. So that's kind of why we have the difference in colors. Okay, so what we could do, I'm fine with just coloring them all blue for this one. Okay, so a couple other things that we have here. We have create new material, new sphere, place duplicates, such like that. So new sphere is going to be used a lot here, where we're just going to continually place new spheres in new locations. One nice thing about this is that we read in all the different colors and everything that we need. But place spheres will come probably in the next hour. For now, we don't need it. Place duplicates, basically the idea is that we create one sphere and then we place the duplicates of that sphere. And the reason we do it this way is because it saves a lot of time in terms of generating new meshes. For some reason that takes a while in Blender. Then we have place spheres. Again, not so bad. This just takes every point in the array and plots it out. Move spheres, this is the thing that actually does the moving. Create cage, this simply creates a box. In the last simulation, we didn't use it. In this simulation, we will. Cage set. Again, this is for placing the box down. And then we have define scene. Okay, so what I want to do is I want to move the camera back a little bit. Now, I don't remember how I got the camera so close. I think what I did is I think I used this one. Let me see here. So let's comment that guy out. Let's go here. Actually, I could probably just do it this way, couldn't I? So let's go up here. I think it was this one that I used. So let's go here, right? And now let's do the last Blender command. So it's going to be blender -b-p determinant.py. And while that's working, let's go up here to the top of this file and change this to determinant.py. .py. And I realize it's kind of messy to go through and just continually rename files like this, but it's okay. .py. Okay, so let's go here and let's see what it looks like. So we're going to run mplayer. Then it should be out.mp4, I believe, because I'm very good at naming things. VO x11. And then what do I want? I want, loop 0. Okay, so let's see. You'll note that this is kind of off-centered and kind of small. Okay, that's fine. That's not, the biggest deal in the world at all. Let's see if we can get it centered again. So let's go down here, G, and let's go up to the define scene. And what I'm actually going to do is I'm going to take the camera angle that we had before, because that did seem quite centered, and then I'm just going to multiply it by some values. So let's go here, remove this line, add in a line here, and go down here. So we have 0.55 multiplied by 2, that's going to be 1.1. Okay, I actually, you know what, guys? This looks, let me run something real quick. Let me run this without VOX11. You guys are not going to be able to see anything. I apologize for that. Yeah, that's totally not in the center. But the last one was in the center, wasn't it? Did I do something to the camera angle? No, the camera angle is still 70 by 145. Was there some sort of shift? Let me see. So I guess we just multiply this again and again. So let's do this. So we're going to do 0.8125. I'm very bad at multiplication. So let me go here, open up Julia. And let's go from there. So Julia. And we're going to say 0.8125 times 2. And it's going to be 1.625. Really? Oh yeah, that's fine. 1.625. Okay, then 0.3615 times 2. And this is going to be 0.723. 0.723. Okay, let's write that. And let's go ahead and move over here and run the last Blender command. Okay, so we're going to do blender-b-p, and let's see what happens. Again, it'll take a while to render each of these, but it should be okay. I'm not so worried about render times here because it's not that long. We used to have much longer render times. Okay, so let's go here to VOX11 and let's see what happens. Yeah, there we go. That looks pretty good. Sure. Why not? Why not? Okay, so here's what we're going to do. We are going to plot, do a couple of different things. First thing we need to do, change the color of all the points so that they're all blue. So let's go up here and let's go to the place spheres command. Where are we? Create cage, move lines. Where are we? Keyframe insert. Oh, okay, yeah. In fact, let me do something real quick. This is kind of bugging me. Okay, so we're going to go down here. And of course, guys, if you have any questions, comments, concerns about anything that I'm doing, let me know and I will totally talk about it as soon as possible. So move spheres, let's go up to place spheres. So what I did here is we gave a vel max and vel min, and then we just kind of used the vel max and vel min to find some sort of ratio, which is dependent on the difference between the velocities here. Now, in this case, this isn't exactly what I want to do. I want them all to be the same color. So let's just go ahead and remove this ratio stuff, which makes this place sphere command a little bit simple, but that's okay. So I'm just going to go down here and say ratio, not ratio. So this is going to be R first. So let's change this to 0. And let's change blue to 1. Now let's do the last Blender command. Check it out, and it should be that they're all blue. And then the next thing we need to do is plot the grid twice. And I know that's going to be kind of weird, but we do want to plot it twice. So the first time, though, we're not moving any of those points. So it should be that if we plot it twice over, yeah, it should be that if we plot it twice over, we do not at all create, let's see, or we do not mess with those points. And they're still black. Oh, wait a minute. They were blue to start. Oh, wow, interesting. The very first frame. I don't know if you can see that, but I promise they're blue on that very first frame. Okay, so they are blue on the first frame. Why are they not blue all the way through? Why do they turn black? Okay, let's see if we can figure this one out. New sphere, we color them based on one. So let's go through to the move spheres command, and let's see if we can figure out at any point when we do RGB. In fact, let me see, new sphere is there. New material, keyframe insert, diffuse color. That's probably the problem. We change the color. I mean, I guess that makes sense, right? So use transparency equals false. That's fine. Let me go up here and let me see. What do? We do a keyframe insert on the speed at which the particles are moving. So that means that based on their velocity, their colors do change. And that's fine. That's fine. But again, in this case, I don't think it's for the best. So let's go through and see, where did I do that before? New sphere here, place duplicates there. Let me see. Copy location, copy name. Where do I change the color? That's the question. Okay, ratio is that. We don't need the ratio. Place spheres, move spheres. Probably use the ratio again there. Max and min velocity, looks like I do. Ratio is equal to this. Diffuse color is going to be here. So let's change this again to exactly what we had before with 0, 0, 1. Now let's do one last Blender command. I say last, but we're going to be doing it a lot, actually. Okay, so we're going to do this, and then let's see what happens. Okay, and then the other thing is I have to make these spheres a little bit smaller. Well, maybe not these spheres, but we're going to have to place some small spheres. There we go, so it's blue the whole time. Good, that's what I wanted to see. Good, that looks pretty good. Okay, so now we have to place a new a box around this, right? And we can do this in a number of ways. We know the final position of all of these objects, so we can just use that final position in order to place the box around the object. So where are we? We are, let me go up to the top here, and let's see, we have parse data. That's fine. Let's go down here. So we parse data, and then we do this. So we remove object scene. Let me see. Scene update, render movie. Okay, so at this point, after parsing data, we then need to, oh man, I'm so tired. We then need to go down here and add in a few more frames. So these frames are going to be where we add in the extra stuff for the determinant stuff. So adding in extra functions for determinant visualization. Okay, so what are we going to do? I guess we're going to say a big function called visualize determinant. Why not? So we'll call it, what do I want here? Visualize determinant. Okay, so we need a couple different guys here. Let's go up here and go ahead and define the function. So define visualize determinant. Okay. Pop it down here. I don't think, actually, I do think we're going to need something. We're going to need an XYZ position of the box itself. So the box will be of some, how do I put this? It will be of some dimension, right? And so we need the XYZ position or dimension of the box. So here's what I'm going to do. I'm going to say, I guess it's just dimension. That's fine. We'll call it plural. Okay, so now what we need to do is create a cube of the appropriate dimension. So let's do that. So we're going to say, I think, unless I'm just completely off my rocker here, I think all we need to do is cage set. Maybe we have to create cage first. Let's see, box length. Yeah, box length and sign. What does sign do? Sign is there. Sign is there. Location is sign. Times box length over 2. Huh. Why did I put a sign there? I'm not sure. Okay, but this should create a cage. Let me see. Do I use the create cage function? I do. Good. Okay, so we should just use the cage set thing, and this should work. Now what we want to do is increase the total number of frames by just 1 or 2. Just so that once we add this cube in, it'll be there for like a few frames, and then we'll just kind of call it at that point. So let's go down here. Let's see, number. where are we doing that? Number is equal to parse data. Now let's go down here and say number plus equals, I don't know, 10 frames or something like that. Just so that we know it's working. Okay, visualize determinant. Let's go here, and I think it was create cage. Dagnabbit, I forgot. That's what I get. Okay, define scene, cage set. That's what I want. Let's go down to the bottom. And let's go here. So we're going to say cage set. And we're going to set box length equal to dimensions. Actually, I should just call it box length. Why not? We'll call it box length because that makes a little bit more sense. Okay, and then sign is going to be just, I guess, always positive. Okay, let's go down here, and when we do visualize determinant, let's add in, I'm just going to call it a box length of 1 for now, just to kind of give it some sort of space to be created and stuff like that. Okay, so this should create the box. So let's see what happens if we write and we run the last Blender command. It looks like we're rendering, so that's fine. We're going to see how many frames we get. We should get 70 frames. We'll see how far we get. Okay, so this is 50, 60. Oh, we're good. We're going to 70. Good. Okay. So let's see what happens. So we're going to do mPlayer out. Oh, the cube is always there. Well, that's good. Not exactly what I wanted, but that's okay. How do we make it so the cube only appears at some point? Let's just... Wait. It kind of looks like... Does this not look weird to anyone else? Let me open this up in Blender. So let me do blender-p determinant.py. This will open up Blender. It'll run the script. So while it's running the script, let's go ahead and move this over to the appropriate location and give it a second for the graphical glitches to disappear. I apologize. We have to wait for all the frames to be appended. And good. Okay, so this is what we've got. It looks like there's a cube in the middle. Each of these points, though... Oh, we're not at the start. Okay, there we go. So we have 1 cube, 2 cube. Okay, now we go all the way up here. And it looks like we have... Should be a few frames, yeah, where the cube is not moving at all. Good. Cool. Okay. So what we have to do is make that cube big enough that it is over this entire area here. And that's not so bad. We know how big it should be. So let's just go ahead and do that. So what are we going to do? Let's go ahead and go to out.dat. Down to the very bottom. And it looks like the biggest number here is going to be 3. So we'll just make it 3. Box length 1.0. We'll make it 3.0. Let's go over here. Let's go ahead and quit. And here's what I'm going to do. I'm going to go and not render the scene in this one. So we're going to do that. Let's go here to blender-p determinant.py. Oh, okay. Warning, invalid encounter due to double scalars. That's fine. We don't use that. Okay. So looks like I was incorrect about my previous assumption there. So here's what we have. The giant cube is not at all... Yeah, okay, so we need the cube bigger, and we need to be positioned at a different location. So let's go through and do that. So I'm going to set the cube to be super big now. Let's change it to 6, because that should be big enough. Okay, now let's go through and put it into the appropriate location. So we have box length. What do I want? So we want to go to the create cube, where we define scene, cage, set. This is what we want. And we want the location just to be 0, 0, 0. We don't have to worry about sign or anything like that. Location equals 0, 0, 0. So let's go ahead and remove this line. Wait, did this even work? Sign. Oh, wait. Yes, okay, that's why it worked. Good. So let's remove this line. Let's change this to 0, 0, 0. 0, 0, 0. And add in this guy. Now let's make it one more time. Blender-p determinant.py. And let's see what we got. So it looks like at this point we don't have a cube. Well, that's interesting. What did I do wrong? Let me see. Connect failed, no such directory. Blender determinant pi. Length of connecting is 12. Importing data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, there are 12. Okay. Let me see. Cage set takes one positional argument, but 2 were given. Oh, fair enough. So let's go up here, change this to an X, down here to the bottom, and let's change it here. I'm sorry. Where are we? There. Nope. Here. There we are. Right, this go over here, and now Blender-P determinant pi, and we should see, yep, a giant cube, which looks like it does cover the entire transformation. What? In a way. Okay, so yeah, so let's see what happens. So now I'm gonna render it, and let's see what it looks like. I bet you the camera's in the wrong spot, but that's okay. We can change that pretty easily. So we're gonna do Blender-P determinant.py, and we want to do -b-p. So the -b makes it so it runs only in the terminal. So here we are rendering all the frames again. Okay, they seem to be rendering quite quickly. I don't remember if they were rendering this quickly before, but that's okay. We'll see what happens. Again, 70 frames for this animation. Okay, let's see what happens if we do the last mPlayer command. Okay, so this is what we got, F. So it looks pretty good to me. I mean, it looks like the interior box is completely within the exterior one. And that's exactly what I wanted to see. So now we have to make the exterior box appear after the interior box has already done its transformation. And that's fine. That shouldn't be so difficult. Okay. Yeah, it's looking okay. This is looking okay. Okay, so now we'll go from there. So what do we want to do? Let's go through and say, let's see, we have box length. What was I doing before? Let's see, every time frame, every time step. Let me see. I know I was reading in frames somewhere. Okay, so we have 4 line in data. What do we do? Number of frames is going to be equal to the number of lines we have. So that will be 60 frames because it's a, kind of quick transformation. And let me just kind of change a couple of things real quick. So first of all, when we do the connectomy thing, let's go down to create connectomy. Let's see what we have here. Create connectomy. Let's change the size here. Connectomy for range, print, return connectomy. Oh, that's fine. That's not what I want to do. Add lines. This is what I want. Okay, what do we have here? String 0. We're adding in curves. Let me see. bpydata.curves. Bevel depth. Bevel resolution is 4. Fill mode full. Splines. Let me see. 0. This is always annoying. .co. Let's see. Create new material. Curves. Append matte resolution 0. How do I change the size of this curve though? That's the question. Let me see. bpy ops. Bezier curve add. Let's see. bpy context active object ID name BC, which stands for Bezier curve. Let's see. Bevel depth equals 0.03. What happens if we drop this? Let's go here. Let's run Blender-B-P, and let's see what it looks like. Give it a second to run, and then we'll be good to go from there. Again, if you guys have any questions, let me know. I'll totally answer them as soon as we see. But again, today's kind of more of a relaxed day. We're just visualizing stuff. So let's run mPlayer. Good. So that did change the size of lines. That's what I wanted to see. Okay, so now we have to change the size of the balls. You know, we don't want really big balls. We want them to be kind of small. Okay, so let's see. What do we have here? The actual size was determined by, let's see, create cage, move lines, move spheres. Where's create spheres? Place spheres. No. Diameter. That's what I want. Let's drop it by 1/2. 0.5. That was 0.05. We do not have an IP address here. That is also too big. We want it to be 0.05. Now let's go ahead and make it. I'm sorry. Blender-B-P. Let's see what happens. So it's obviously much, much faster than the last one. Maybe not. I don't know. I'm making things up. It just feels faster to me. And that's okay. Okay, so now we have 60, 70. Okay, so let's do Blender-P, actually mPlayer, and let's see. Okay, this looks pretty good to me. Now what we need to do is make that cube appear after the transformation has occurred. So let's see, what do we need to do here? Let's go down to the bottom. And what I want to do is add in, let's see, bpy scenes, scene frame end equals num. That's fine. Let's do the visualize determinant function after scene update. So we're going to do visualize determinant of 6.0. And let's see what happens if we do it this way. And then we have to do another scene update. Now let's do blender-b-p, and let's see what happens. I don't think this is going to work, but I thought I might as well try it. So we'll see. I think we actually have to give it a time frame in which it is, or a frame in which it's created. So let's do mplayer. Yeah, so the box is still there. I mean, somewhat obviously, right? We created the box, but it doesn't really care when we created the box. So let's see. I have to go through and figure out how we dynamically place the particles. So let's go up, create connect to me. Let me see. I use the frame a lot. Let's do frame. First frame. Number add strings, particle in the first frame. At frame. Okay, let me see. Move spheres. Keyframe insert. Let's see. Frame. Max val, min val. Frame set. Frame. Offset. Current frame. Let's see, what do we have here? Keyframe insert. Let's see. Frame, 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 frame. Lots of frames. Let's go into the Blender guy. So let's just do blender-p. And let me go down here and not render the movie. And let's run it. Okay, this obviously appears quite quickly. Now what we want to do is see what kind of stuff we can do for this box here. Move this over here. The box is going to be, I think I'm highlighting the box right now. Yep, cube 001. Okay, so we want the cube, let me see, start to not appear back there. So we want it to appear at this point. So let's go up and let's see what we can do with this guy. So we have animation. No, I don't want to click that button. Let's go here. Add to groups, name, textures. I don't know. Nope. It is wire. That's fine. That's what we want. Material maybe. I guess we have to insert a keyframe, don't we? So let's see. Is there some way to insert a keyframe? Let me think. Maybe we click on this guy and do edit translation. Translation, that's not what I want. Wire. Let's see. Axis, bounds. No, this is what I want. So let me see. Having the box there isn't that big of a deal. It's just kind of weird looking to start. Okay, so let me see. 1 second. What are we doing up here? We have, let's see, parse data. Go through all the data. Then we do create new material. That's fine. None of that matters. What we need is this frame stuff that I was looking at before. So 4 lines in data set. If lines, let's go down to find the next frame. Okay, at frame. We move spheres. Sorry. We move spheres array, numpart, lines in data set, max and min velocity. And we move lines connecting lines in data set. Okay. Next, frames. Keyframe insert. Frame, let me see. Move spheres. So this is where we have all the data for this. Say bpy context scene frame set frame. Okay. Now we say offset equals int. Let me see. Int frame times number of particles times minus number of particles. Huh. Okay, so I'm not sure exactly how to do this. Let's mess around with this bottom part here. So we want to do a scene update. We don't want to change the number yet. What we want to do here is say number is going to be equal to visualize determinant here. And let's go here and return number. And in here, we're going to read in number. 1 second. Good. Okay, visualize determinant. And we're going to read in number. Okay. And we're going to say number is equal to number plus 10. So we're going to say number plus equals 10. And the reason I want to do it in here is because eventually the visualize determinant function will become incredibly big, and well, not incredibly big, but it will take a lot of frames. And because of that, we have to kind of think about how we want to do that. Okay, so let's go in here and let's see. This cage needs to be created at a particular frame. So let's go to cage set. Where are we? Cage cube, bpyf mesh add. Here it is, primitive cube add. Okay. So let me look this up real quick. Primitive cube add blender. And let me see if there's a time that we can put it in. So primitive cube add blender. 1 second. There we go. Creating object custom. Let me see. Off primitive. Let me see. Let's say creating a box at particular frame. Blender. Okay, so animation. No, that's not what I want. How to add an object to a keyframe range. Let me see. Scene. What is this guy doing? Okay, well that's fine. He's doing a pulse beam. That's great. You could keyframe the visibility and the renderability of the shot object and the outlier. Okay, so let's see. So how do we make them visible and invisible? So this would mean, and I don't really like this idea, but this would mean that, I guess it's fine. I can't see another way to do this. So, okay. So I guess what they're saying is that what we need to do is keep it invisible and then make it visible at the end. But this means that in the end, because we're going to be doing a Monte Carlo simulation, there's going to be millions of particles that we have to render. And that's going to be a pain in the butt. A really, really big pain in the butt. Okay, so let's see what we got here. Let's go back. Basic animation. Let's say Python. How to add objects on specific keyframes. This is exactly what I want. Okay. Delete existing. Let's see. Driver base method. Frame change handlers. Each object has two properties called hide and hide render. To use Python to set a keyframe for a property, you have to set the value. You then use keyframe insert data path frame. Okay. To keyframe it. So if you want an object to be visible in one frame, you make it visible and then set a keyframe on the relevant frame. Then hide it and add a keyframe to the previous next frame. Okay. So what do we have here? For X and Y in grid size. Let's see. Keyframe insert hide frame F. Object keyframe insert hide render frame F. So how do we make it visible then? Let me see. What are these guys saying? This one uses a frame change pre-handler to remove all cubes marked with a visFrame custom property. Okay. Driving the hide property, simply hiding a cube if its visFrame custom property is greater than the frame number. Okay, this is good. So we're just gonna hide it. That's fine. I don't particularly care at this point. Let's go through and let's do it. So basically all we have to do is take the object, keyframe insert hide at the start of the frame. Right, so we're just gonna say frame equals 0. So we're gonna take this and we're gonna hide it until it needs to not be hidden anymore. So let's go here, create cage set. 1 second, I'm gonna need a quick sip of water. And then we'll be good to go after that. You guys have been super quiet today, so again, if you guys have anything you want to say, it doesn't have to be related to this. We can talk about that. Okay, so create cage. What do I want here? We want to say cage mat. No, I want to say object here. bpy objects mode edit object. Let's go here. Object. So let's see. bpy ops object. That's what I want here. So we're gonna say bpy ops.object keyframe insert hide frame equals 0. Now let's see what happens if we run blender dash. Actually, let's run here. Let's render the movie. And let's put scene update afterwards. We probably don't want to update the scene after rendering the movie, right? Let's go here. Let's do scene dot update. Let's go here. Let's run blender-b-p. Okay, let's see what happened. Let's see, 60, 80. Let me see. Trace back. Wow, this is hard to read. Found 60 and 8 particles in first frame. That's fine. Home visualization determinant 151. Runtime warning, invalid value. Encounter double scalar. That's fine. File. Trace back most recent call. File. Inline 345. Number visualized determinant. So it looks like 345 is where I want to go. No, that's not what I want. 201 is where I want to go. Okay, ops. Okay, so it doesn't like this. That's probably because I need to do object. And let's see what happens. Let's try that. No, okay. So it doesn't like that either. So let's see. Maybe I need to do frame equals 1. Let's try that. No, okay. It says bpy object keyframe hide frame equals 1. Line 187 is the return op call. Self ID cdict. I don't know what this means. bpy opt object keyframe insert error. Okay, so let me see. What else was I adding keyframes to? So let's go to keyframe. Because I know I've done this before. Keyframe insert. So what do I want to do? Let's do... let's see. Keyframe insert. Let's see. So bpy context scene objects. And then I want cube, I guess, because I think that's what I called it. So let's go here and copy this guy. There. Okay. So now what we're going to do is, let's see, cage set. Where are we? We are here. So let's go ahead and copy this there. Okay. So this is going to be objects, and I think I just called it cube, if I'm not mistaken. So I guess let's just call it cube. I think. I'm actually not sure. Let's run blender-p. Yeah, of course it's not found. So let me go here. Let's comment this guy out. Go down to the bottom. Not render the movie. And let me just run blender-p determinant.py. Okay, so I called the cube 0.001 apparently. So let's render it again. Let me go up to cube. And let's change it to 0.001. Let's go here and let's run blender-p. This one seems to run. Good. However, of course it's going to run because, yeah, of course it's going to run. Okay, so let's go here. Let's remove this, write this, go down to the bottom. We're rendering movie this time. Let's just run blender-b-p. And let's see what happens. So rendering each of the frames, everything seems to be okay. Let's see what happens at frame 60. Oh, actually, the cube should be invisible the entire time for this one. So let's do, what do I want to do? No, I want to do last mPlayer command. Here we are. No, the cube is entirely visible, which is the direct opposite of what I wanted to happen. So let's see. Let me go down to render movie. Let's write this, go to mPlayer. No, I want to do blender-p determinant.py. Let me see. So yeah, it should be visible. Let me go down here. That's what I wanted to do. Let's see, .hide. bpy objects data hide. Okay. So let's try going up here. And let me just see what happens if we just run .hide. It should hide it the entire time, and we shouldn't see so much trouble with this. So instead we're going to do this. bpy .context .scene .objects cube 001. And then I want to do a .hide. I think that should work. maybe it needs a... Yeah, okay, so apparently it doesn't like that. Let me see. Wait, are you kidding me? This is exactly what it told me to run. Let's go down here. It is .hide. Okay. So it doesn't like that. Let's see, object, mat, return cube. Object mode set object. Maybe it's because this hasn't been created yet. So let's go down here to before returning the cube. Let's do it here. Okay, right here, let's go to Blender-P. Nope, it's still there. Totally still there. Okay, let me see, cage set just requires box length. Let's try putting this down in here. Cage set. Let's go to Blender-P. Determinant.py. Totally not invisible. You can still see it. It's right there. Why is this not working? Scroll down. Hide. What the heck? Okay. Not sure exactly what's happening here. So let's see. DD. Let's go up to the cage set command. Where are we? Cage set. Here. Okay, so it doesn't like this hiding thing for some reason. Not exactly sure why. Dang. Okay, so that's okay. Okay. Let me go ahead and check my stream real quick just to make sure I'm still up. Okay, I guess I'm still up. Is the chat not working? No, okay, that's fine. It's weird. You guys are not saying anything. It's like freaking me out. Okay. Good. So be by context scene objects hide. We're not hiding at all. Okay, so let me open it up one more time. Let's see, what do we have here? Found 6080 particles, warning, invalid value, reference encounter double scalar. That's perfectly fine because, it's okay. What this is basically saying is that we are reading in all the velocities the same. So it basically means that velocity minus min velocity divided by difference velocity is not a valid ratio, which is fair enough because it's going to be 0. No, you're okay, Gustron. It's just... I was a little bit worried that something was wrong, but it's okay. As long as everything's going fine, it's okay. Okay, so we have material cage set material cage. Okay, let's see. BPy ops data mode set object. Let's see. Define object. I had a 12-hour drive yesterday. Yeah, actually, how was your time off? I'm glad you're back, by the way, but I hope that it all went well. I know you said you were without internet, which is probably a little bit stressful. But I hope you had fun while you're out. So, okay, let's see, what do we have here? Cube 1, hide. Let me check this again. Blender-P, Determinant.py. And here's what I'm going to do. I'm going to go here. Again, one of the advantages of Blender is that we have a Python console. So let's... Oh, good. I'm glad you enjoyed it. Let's go here. 1 second. Good. Okay, so what do we have here? We have BPy data objects cube 1. Let's see, what do we have here? What am I running? BPy context scene objects. So let's do BPy data objects. And let's see what we got. Blender-P. Still there. Dang. Okay, so let's go here. Let's open up the Python console. Okay, good. That wasn't what I wanted to do. Wanted to do this one. I guess it's at the right size. That's fine. Okay, let's open up the Blender, the Python console. Let's go here. What do I want? Python console, where are you? There you are. I'm gonna run BPy. BPy. Dot data. Dot objects. 1 second. Then cube001.hide. Is it objects? It is objects. Then I want to do cube 0.001. Let's do dot hide. False. Are you kidding me? Okay. Got it. It returned a Boolean value. That's fine. Okay, so we're going to insert a keyframe that says the following. So it's going to be bpy.data.objects cube 0.001. And then we want to say dot keyframe insert what do I want to do? Let's do hide at frame. Sorry about that. Frame equals, what do I want? I want frame equals, I guess we're going to read in the frame. So we'll say frame equals create, I don't know what to call it. Make box, make frame? Main frame? No, that's probably bad. Equals true. Oh, false. Okay, let's see what happens when I run this. It's probably not going to run okay. Let's go here to make frame. Let's go down here and let's read in that as number. Okay, let's write this, go over here, and let's do blender-p. That didn't do anything. Okay, let me go here. I've got a feeling I did something stupid. So let me go back up to, where are we? Add cube or something like that. bpy data objects cube keyframe insert hide equals false. Can't assign to function call. Oh. Let's just make sure this runs. So we're gonna run blender-p. It does run. Okay, good. So we don't have a box. It's exactly what I want to see. Now let me check how I did the other keyframes. Keyframes. Here. Next. Keyframe. Here, insert. Data path, co. Bezier points. What was I doing here? Keyframe, insert, data path, co, frame, index. Okay, I see what I did. Okay. So what you do is you say, and this is kind of weird, to do the keyframe, you move the curve into the appropriate position, and then you add the keyframe. So let's see what happens if we do it that way. So we're going to say, let's see, cage set down here. So we're going to say here, this is going to be that, and then we go bpy, let's remove it here, bpy.data.objects cube. I'm just going to basically take this guy. And now we're going to change this to false. I don't think this is going to... Let's see what happens. Blender-p. Okay, so we don't have a cube at all. Let me see. Is there a... Down here, cube. There is no keyframe inserted. So let's see what happened wrong here this time. Cube doesn't exist. Fair enough. Try it again. Okay, so it is there. It is there the whole time. Darn. Okay, so let's see. What else do we have? It says cube doesn't exist. Blender. Okay, so it says this one should work, but it obviously doesn't. Let's try it the other way. Oh, this is because I forgot to do this. So let's try it again. Clearly no keyframe inserted. Oh, there is a keyframe inserted at 60. So let's go down here and let's see what we have. Cage set number plus equals 10. Return number. We should be returning the number. Number is equal to, why is the number not increasing by 10? This is like a super simple Python thing and I can't get it right. Okay, so we have visualization determinant, 6.0 reading in the number. The number is equal to parse data. So let's right here just print out the number. Should be 70. Let's do Blender-P. It is 70. Okay, so what did I forget to do? I forgot to increase the number of total frames. So let's go here and copy this under this guy. And now let's remove that, remove this, right, and let's go to Blender-P. Okay, now let's see what happens. There is a keyframe there, but I don't know what it's actually doing. That doesn't really help, does it? It looks like it's always visible. But there is totally a keyframe at 60, so we're getting there. We have a keyframe. Now we have to figure out how to make the keyframe act on the box in the way that we want it to act on the box. So let's go to the keyframe. And here's what I'm going to do. I'm going to try doing this the other way around. So where is add lines? What are we doing here? Let's do here. Hide. Yep, that's what I want. I want to do it here. So let's do this there. Now let's run Blender-P. See what we got. Okay, well, we saw a cube, didn't we? I thought we saw a cube. Did we not just see a cube? Let's do this again. Let's run Blender-P. There is a cube. There is totally a cube. There's not a cube. Shoot. Let's run the movies. Let's see what happens. Let's go down here, down to the bottom. Let's run to the movie. Let's go here and let's run Blender-P -B-P. So -B. Okay. Give it a second to make its stuff, and we'll see what happens. Okay, so we have all 60 frames being created. Oh, 70, sorry about that. And let's go to the last mPlayer command. Okay, so it looks like the box is always there. Didn't even try. Didn't even try. Dang it. Okay, so let's see. How do we do keyframes then again? So let's go up to keyframe. Keyframes, like, I don't know. They just don't make sense to me in Blender. Okay, so we have keyframe insert. Say if temp mat is equal to none, return temp mat. Let's see. New. Let's see how they did it before. So let's do here. Keyframe insert hide frame F. Let's see. For wine range. Object keyframe insert hide. Object hide equals true. Object hide render equals true. Key as hidden on the previous frame. Keyframe insert. For X in range grid size, for Y in range grid size, F equals X times grid size plus Y. BPy ops mesh cube add. Okay. Objects primitive cube context object hide or active object. Keyframe insert. Hide. Frame. Object hide equals true. Okay. Key is hidden on the previous frame. Maybe I have to do hide render. Let's see, where are we? Move spheres, move lines, create cage. Let's go to hide render, maybe. I don't know what that happened. Let's see, hide render equals true. Okay, let's see what happens. So we're going to basically copy the same guy, except change it to hide render. Hopefully that fixes something. So let's do mPlayer Blender-B-P, and let's see what happens. I just realized I think I did this incorrectly. I think we need to do it up here. No, I'm not using Windows. Why would I use Windows? Okay, so we got here, BPy data objects. Let's go up here and do hide render. I think I see what just happened. So we want this to be hide render. Okay, now let's try it one more time. Blender-P-B or whatever. Okay, I think what I did, if I'm not mistaken here, is I went through. Oh, no, I'm not using Windows. Wait, did I say I was? Anyway, what I think I did is I hid it. And I'll show you where I think I hid it. Oh, nope, I was wrong. I was totally wrong. Dang it. Okay. So let's see what we have here. Hide, true. Hide render, true. Should be hidden. Keyframe insert. What if we change these guys also to true? So no matter what, it's always hiding. Let's do blender-b-p. No matter what happens, should totally be hiding. Okay, give it a second. Okay. Now we're going to run mplayer. Okay, so this is totally hidden. The box is gone. Okay, so let's go through here. Let me see, what did I do? I changed it to number. Number should be 60. We are adding a keyframe at the appropriate spot, but for some reason it's just not working. Which is fine, you know, we just have to figure out how to get it to work. Again, not an issue. We will figure it out eventually. So, we are hiding the whole time. Let's see, keyframe insert. Maybe I'm doing this opposite of how it's supposed to be. Let's change this to false. Let's change this to false. Let's do blender. Let's see what happens. Man, I just don't... I hate keyframes. I mean, at one point they made sense to me, and then I spent like a month away from them, and now I don't get them. I learned them... Let's see, so there is no box. There is no box, period. Okay, so the keyframe is just not working. Okay. Hide. Yeah, okay. So we're just not reading these guys, which means the keyframe is just not being inserted, which is fine. Okay, so now we have data path location, frame equals current frame. Okay, so what are we doing here? We say we are inserting a keyframe. bpy context scene object string data. So we're taking the object, we're adding a keyframe. bpy context scene objects. So we change the location first, and then we add in a keyframe. We change the material, then we add in a keyframe. That's what we're doing here. So let's go down here to the bottom, and let's just make the object hidden, and then we're going to add in a keyframe to make it appear. And let's see if that'll do something. Okay. So what do we want to do? We're in cage set. Let's just copy this guy here. And let's bring him down to another place. A better place. Right here. Let's try that. Blender. Keyframe insert hide. Name make frame is not available. That's fair enough because it should be number in this case. Let's try it, blender-p, and let's see what happens when we render it. Looks like it's going just fine. 30 something, 40 something. Almost there. Okay. Now let's see. mplayer, F. Okay, the cube's always there. Why the heck is the cube always there? Okay, let's go here. Let's see if we can learn something from here. So we say for x in range grid size, for y in range grid size, F is equal to this. We say bpy ops mesh primitive cube add, so we're adding cube to every point in the grid. Then we say object is bpy context active object. That's fine. Now we say object keyframe insert hide at frame equals F. Where does he define F? F is equal to that. That's fine. Object keyframe insert hide render F. Hide equals true. Hide render equals true. Key as hidden object on the previous frame. Keyframe insert. What? Okay. So at some frame, he wants to hide the object. So he adds in the keyframe. Then he hides the object. Then what does he do here? He says key as hidden on the previous frame. Key is hidden on the next frame. Let me see. Object keyframe insert. It looks to me like we're hiding. I don't like this at all. Object.hide equals true. Object hide render equals true. I guess we just flip it around? I mean, this is just such a convoluted way to... Okay. Let's do, try it again. Why not? What's the worst that could happen? It just breaks again. And again, all we're trying to do here is make it so the cube only appears at a particular time frame. So we're trying to hide it, and it's going to be hidden until that time frame in which we want it to be created. So let's go here and let's try mPlayer, and of course the cube is always there the whole time. So again, it's this exterior cube that we're trying to get rid of. I just don't want it to appear until a very particular time frame, and that is when the object stops at the end. So I want it to appear right here. So right at the end after the transformation, I want then the object to appear. Okay, so what is the issue here then? The issue is that I can't figure out freaking keyframes. So let's go up to, I've used keyframes before, and every single time all I do is I change the value and then insert a keyframe. Let's see, what's the next keyframe? Index -1, keyframe index, location path, frame, current frame. Keyframe insert, data path co, fair enough. Frame equals frame index -1. Yep, okay, keyframe insert hide, frame equals number. Okay, frame equals 1, index equals -1, data path diffuse color. So this is us changing the color of the spheres as they go through. Okay, next with a keyframe insert, data path diffuse color, frame index -1, again, changing the color. Okay, data path co. I don't know. This totally should not be doing this. Let's do this to, I don't know. Let's try this in Blender. So let's just do blender-b-p determinant.py. So I'm actually going to open up the Blender. Oh, well, not this time, but I'm going to try it. Because like that was the last resort. I can't figure this out at all. Then I'm just going to try adding in a keyframe. And we'll see what happens. Let's do mPlayer. Okay. So let's go here. Let's run, not render the movie. Go down here to the bottom. No rendering of the movie. Let's go here to blender-p. So we're just running the Python script. Now here's what I want to do. At this point, we have a keyframe clearly we have a keyframe. So I want to see how do we check what the keyframes are doing. So let's go here and let's see what we got. Cube. Let's check this. Enable physics for cube. Material. No, this is what I want. Let me just Google keyframes Blender. Object. Okay, actions, keyframe object layer, weirdness, Blender basic animation. This is not what I want. I just want a very simple, man. Okay, let's see, location rotation, insert keyframes. Okay, let's do here. So we should have clear keyframe. I just want to check the keyframe. Let's see. Add to keying set. Yeah, that didn't do anything. It's now constantly hidden. Remove from keying set. Add to keying set. Let's see, where are we? Clear keyframes. So now it's always hidden. So we want to do insert keyframe. At that point, that's fine. So that's fine. Clear keyframes, add to keying set. But now what do we do? There's a keyframe there, but it's not actually doing anything. So we want to delete keyframe. Let's go here to add to keying set. Insert keyframe. Now how do I take a look at what the keyframe does? Let me see. I don't know. I have no idea. Clear keyframes. Remove from keying set. Okay, so we insert, oops. Insert keyframe. Cube 1.hide. Replace keyframe, that's not what I want. Let's go down to other things that we could possibly do. So let's do cube. Let's say insert keyframes. Okay. Now, what did I just do? Let's not hide it. Okay, let's clear the keyframe here. Let's not hide it. I'm not really sure what it's trying to do. I have absolutely no idea. Here's the cube. It clearly is not moving. Insert keyframes. Let's move it over here. Okay. So there we go. Let's see what happens. Nothing. Absolutely nothing. Shoot. Okay. But I clearly did just move it. So let's clear keyframes. Let's insert keyframes. Let's move it. Now let's see. Replace single frames, delete keyframes, clear keyframes, clear single keyframe. Clear single keyframes, add all to keying set. Nope. Doesn't do anything. Dagnabbit. I mean, I have keyframes on everything else. So let's delete keyframes here. Let's just remove the freaking cube because it's completely unnecessary. Okay, so look, each of these guys has a keyframe. Look, all of these keyframes. That's how they're moving. Okay, so let's see what we got. Why is this such a pain? I don't... All I want is for a box to appear at a particular frame. That's all I want. How do I clear... Python, location object is specific frame. Okay, what do we have here? Location. Let me see. Object, active object, frame. Wait. Are you kidding me? There's a frame set option. Let me see. What do we have here? Cleanest way is, let's see. Try using frame set instead of directly setting the current frame. Let me see. Frame set, bpy object scene frame set. Let me see. So object bpy active object object location, position 1, bpy context scene frame set. Okay, let's see what happens if I just do that. So let's do here. We're gonna do bpy. Data dot scenes. Let's see, what is it? Context scene frame set 1. Context scene frame set num. Let's try Blender-P. Hey Patrick, what's up? Gosh, this was supposed to be done by now and I can't get this one thing fixed. We are doing a very super incredibly simple thing and I'm failing miserably at it. Oh, I'm sorry. I thought you were Patrick. I just read the P. Pretty on. We are working on a very simple animation of basically a matrix transformation showing what the determinant is. However, I'm failing miserably at adding in a freaking keyframe in Blender, and it's kind of frustrating, so I apologize for that. Anyway, let's see what we got. So let's do hide. I might as well just not do anything. This is just all just not working. Okay, so let me see. Okay, let's go back a second and let's see what we got. Running script each line. So let's see. All I want to do. Okay, each object has two hide and high renders. The first is viewport visibility and second is render visibility. To Python, set a keyframe for a property, you set the value, then use keyframe insert. Exactly like what I wanted to do and what I thought I did. So let's go here and let's try this way. Let's remove that right here. Let's do Blender. Of course, it's constantly visible because for some reason I just can't figure out how to do these freaking keyframes. Okay. So let's see. It says BPy objects cube add. So they add in the cube. They set it to be the active object. Then they say keyframe insert hide frame F. Okay. Then they hide it. That's fine. That is also what we did. What happens if we just, why not? Let's also, sorry, I hit the microphone. Let's also do, I don't know. This doesn't make any sense. Let's just also do that. Why not? So let's go here. Keyframe insert. For some reason, they are also adding in keyframes for the frames before and after. I don't know why, but let's see. Oh, is it because I didn't do... Maybe that's it. Maybe I also need to do one for hide frame. Hide frame. If this is it, I'm gonna be super... I mean, I guess we're done. Okay, let's see, what do we have here? It is not... I'm not sure what just happened. Blender-P. Yeah, I'm not sure what's happening. Are we generating a cube? We are generating a cube. Okay, so let's go here and bring these guys down here. Blender-P. Yeah, I'm really not sure what's happening here. Let me see. Object keyframe hide frame. Not found. Let's use this hide render. Okay, let's go here to hide render. Right this, go to Blender-P. P. We have a keyframe, but it's not doing anything. Dang. Dang. Okay. Exactly what happened last time. Let's try flipping the order again. I'm not expecting anything really big here. Right this, go to Blender-P. See, and then it does that thing. And I'm not sure exactly what it's doing. So, we run this, right this, go here to Blender-P. Okay, so here's the cube. It is clearly there. It's visible. It's not visible anymore. And I'm not sure... I have no idea what's happening. Like, it just doesn't make any sense. Okay, so keyframe insert, hide render. Frame number. Okay, let's see. They also do two other things here. They say object hide true. Why not? Let's add this down here. And let's do frame equals number minus 1 plus 1. Why not? Let's go here and let's try it out. So now we have 3 keyframes. I'm not sure what just happened. It is invisible here. It is visible here. Okay. Well, let's just remove this guy. Visible, invisible, visible, invisible, visible, invisible. Okay, well, I want it to be the other way. So I want it to be invisible. So I guess I just go up here and I say, move these down 1. And I change these to true. Blender-P. It's invisible, it's visible. Nope. Nope. Nope, it's not liking that. Okay. Let's add in this last keyframe again. Blender-P. I'm not sure what's happening. So let's go here. Let's see. So we have, I think it's because we do hide. So let's try the following. So let's try changing this to num -1. Change this to number. And then we're going to comment out these lines here. And now let's do blender-p. What? Why is this not working? Oh, I know why it's not working. This has to be here. This has to be here. These are the ones that I want to comment out. Okay, so let's change this. Let's change this. Change this to frame equals number. Okay, now let's try that, right? Let's go to blender-p. Okay, so that didn't work. But if we change these to num -1. Yeah, I know, right? -1. Crams hasn't been here forever. Okay, I don't know why it worked, but this one worked. No idea. Sorry it took me an entire day to do that, guys, but I think this is what happened. I'm not totally confident, but here's what we did. Okay, so we hid the box. In fact, I think if we remove these lines, I think we should be okay. Yeah, okay. So here's what we did. When we initially created the box, we hid the box. Okay? So we had to create a keyframe up to which we hid the box. And then after that, we had to add in a new keyframe for which we made the box visible. So let's go here. Let's move these guys up to our cage set function up here. And then we're going to start working on the next step for the next 5 minutes. Again, guys, I totally apologize for taking so long with this. I was not expecting it to take this long. Okay. Let's remove this. Let's change this to frame equals make frame. Sorry about that. Here we go. Bring this down here. Gosh, that took forever. And again, I apologize for taking so long with that. Tomorrow should not take nearly as long. I think we should be able to finish tomorrow actually early, because tomorrow all we're doing is Monte Carlo again, and that we have a pretty good grasp on. So make frame. And unlike the previous Monte Carlo code that we were working on, this one is, I mean, we don't have to make our own stuff. We have everything already made for us. So again, this should be pretty easy. So we're going to do make frame. And then finally back here, make frame. Okay. Let's go here, make frame. Go down to the bottom. Let's remove this stuff here. Okay, and let's see what happens, right? Let's do blender-p. Make sure it works. It seems to work just fine. Okay, so now let's do render the movie. And let's do blender-p. And give it a second to render. Okay. So once this is rendered, we then move on to the next step, which again is super easy in this case. We basically just have to create a random distribution from the box length that we've given it and go through and what do I need to do? Let me run the last mplayer command. Full screen that. And we see boxes created at the end. Good. That's all I wanted to see. It took me a full day to get to this point. Anyway, so what we need to do now is start working on the actual Monte Carlo stuff. So again, there are a whole bunch of different ways in which we can show what a determinant is. One way, which is maybe the least intuitive way, but is a way that I think will make visually compelling sense, is to perform an integral of this guy and show that the difference between the areas, rather the ratio of the areas, is the determinant of the matrix. So we'll do it that way. Okay. So let's go here, and let's go from there. So let's see what we need to do next. So we have set the cage. Now we need to do this. We need to say, we now have 3 boxes, and we have to read in all 3 boxes. So we need the position of the interior box, the interior exterior box. Oh gosh, actually wait, I need to do one more thing, don't I? Okay. So what I also need to do is I need to place all of the spheres initially at a particular location. So let me go and do that. So at the very start, let's go up to 1. And let's see, where are we? Where do we do the initial move spheres if lines and data set in range? That's not what I want. Where are we? Move spheres, move lines. But where do I do the initial place spheres? Print input, place spheres. Here we are. I want to place them twice. Let's go here to Blender-B-P, and let's see what happens. I think this is just going to create 2 spheres in the same location. So I have to do one more thing before the end of today, but hopefully this won't take very much time. 1 second. Let's see what we got. M player out. Okay, so we're kind of getting there. I have to do one last thing here, which is going to be, see, place spheres, add lines. So let's do add lines to the connectomy. I don't think this is going to work. I think this one's going to break because I have to fix the add lines command. I'd be super surprised if it did work, actually. But again, I want 3 boxes in the end. The box that we initially started with, the box after transformation, and then finally the exterior box for which we'll be using to do the integration. So let's see, what do we have here? Let's do M player out. Oh, actually, that worked just fine. Look at that. Okay, so we have the interior box, the box before transformation, the exterior box, which is the box after transformation, and then we have the final box at the very end. Okay. That looks okay to me. That's fine. Now I realize at this point it looks kind of hard to visualize, and I get that. So what we're going to do is we're going to do the visualization with a whole bunch of colored spheres, and we're kind of going to go from there. So at this point, let me see. Let's just draw this. How about we do it this way? So how about we, what we need to do is probably put that last box in, or the initial box. Okay, so we have 3 boxes, right? And again, because we're performing some sort of integration here, this is the last position that we're going to be in. So we're going to be in this position, and then we have our 3 boxes, and we just perform the integration with the 3 boxes. If it's in just the exterior box, it's going to be blue. If it's in the middle interior box, it's going to be yellow. And if it's in the central box, it's going to be red. And then we just kind of make the spheres kind of translucent. We plot a million of them, and then there we go. We have our integral. I was expecting it to look a little bit different. I think maybe we should do a different transformation to make it look a little bit cleaner, I suppose. But that's not a big deal at all. That's actually super easy to change, so we don't have to worry so much about that. Okay, at this point it's 6:58, but we've made enough progress, and unfortunately the next step we have to actually start some new stuff. So I think I'm going to go ahead and call the stream a little bit early. So let's go ahead and commit what we have done so far to GitHub so you guys have access to it. Let me ls. Let me do git add determinant. I think just star will work. Now we do git commit. Adding skeleton code for determinant visualization, which we'll finish up tomorrow. Again, I apologize for hopping back and forth between so many different topics. I realize we have some Huffman encoding stuff that looks kind of okay, and we have some of this stuff that looks kind of okay. We're not there yet. We have a good bit of stuff that we still need to do with everything, and that's perfectly okay. That's how it goes. So let's go ahead and right quit. Let's do git commit. I already did a commit. Git push origin master. Now we're going to do add in a password whenever it gives me. There we go. Okay, with that, guys, I'm going to go ahead and call it for today. Have a fantastic day, night, afternoon, evening, morning, whatever time it has to be your time. I apologize if today was a little bit frustrating. I did not intend for it to be frustrating at all. It was meant to be kind of a fun side project when I was kind of working on the Huffman stuff. But it ended up being way more complicated than I thought it was going to be. But that's okay. That's how programming happens. That's how everything happens, actually. It ends up being a little bit more complicated than you would think. So guys, thanks for watching, and next time we will finish this up. Again, there's not much left to do. Just create a whole bunch of spheres at particular time points, and maybe modify the box that we're editing. We're going to see how it looks. If it looks good, we're going to keep it. If it doesn't look good, we'll kind of mess with it from there. So we've got a few things that we need to fix up, but it should not take more than one more day. So we'll be back to the Huffman stuff on, let's see, tomorrow's Wednesday. No, today's Wednesday for me. Tomorrow's Thursday, so it'll be Friday for me when we return back to the Huffman stuff. And this weekend we should spend most of the time working on the getting ready for next week when we start working on the Vitter algorithm for dynamic Huffman encoding. So I think everything is set to continue working on stuff. We just have to kind of do the stuff, which will take a variable amount of time depending on how good I am at it, and we'll see how far we get. Anyway, guys, thanks for watching, and I'll see you next time. Bye, guys.